Hola, ¿qué tal? Bienvenidos, comunidad. Esta es nuestra tercera virtual, bueno, si contamos como los regulares, las meetup virtuales. Esta es nuestra tercera. Y bueno, también tenemos, ya saben que tenemos nuestras meetup de intermedio. El día de hoy vamos a tener ascendido. Esta plática va a ser 100% en inglés. Entonces voy a hacer el switch a inglés para presentar a Sendil y él ya pueda iniciar con su plática. Hi, Sendil.
Hello.
Good night there in Netherlands. 2 a.m. Sorry.
Yeah.
And do you know that you are the first person talking in English in these virtual meetups for us?
Oh, wow. I'm the first.
It's a great it's such great honor to have you here. Well, Sandil, I will be do a short introduction for you. So you are working currently in Uber. You have been part of the authors of one book. This is book, Full Stack Application Development with JHipster, right? And also working with other open source projects like Webpack and Rust Wasm, right?
Yeah.
So welcome, Sendil, and thank you so much for being part of this virtual meetup for Guadalajara, Mexico. And go ahead, man. It's all yours.
Okay. Thank you very much for the kind words. Hi, I'm Sendil here. Hello, everybody. Yeah, it's my first time speaking somewhere in Mexico. I'm really excited. I would actually, physically, I would be more happy to be there, but the situations are not there currently. But yeah, hello, everybody. This is Sendil here. The talk is about easy microservices with Kubernetes and Istio. And just the chat is over here. So any questions, if you have in between, just stop me and ask questions. Feel free to do that. So a little bit of introduction about me. I'm Sendil, and I'm actually from southern part of India, Tamil Nadu, and that's where I originally come from. Right now, I'm living in Netherlands, actually southern part of Netherlands, and I'm a software engineer, and I'm also a team member at JHipster. So that's where this talk is entirely surrounded. So what is JHipster? How it helps you to do microservices? And how we help you to deploy your application with Kubernetes and Istio. And we will also try doing a Kubernetes and Istio deployment today. So that's it. That's an introduction. So what we are going to see today, basically, why microservices, the basic question, why do you need it? I'll quickly run through what are the things that you have to see when you're doing microservices, and then what is Kubernetes, how it helps in the microservice architecture that we're going to take, and what is Istio, and finally, what is JHipster and how it helps. So let's start with microservices. Why microservices? I mean, this is right? So there are two different paradigms. One is microservices, another is monoliths. Monoliths are simple, it's faster, but on the other hand, a monolith actually ties you to one single technology stack. So if you're traditionally developing in Java, or traditionally developing in Go, you actually tie yourself on that single stack, and then you try to implement solutions around it. And that is a huge drawback. And you cannot scale it easily. Monoliths are very good when you start your application, but over the time, if you want to roll out new features, if you want to add more stuffs to your application, then the problem is there. So you cannot scale it very faster. This is what monoliths are. So it's a single application, everything bundled together in a single package. On the other hand, you have this microservices, which is at the other end, where you deploy multiple different services. Each has its own service. Each has its own usage and then use case, or it is focused on single isolated entity. And which means like each bit of the services are scalable. So you can scale it at any point of you want. And then each bit of the services that you have can have multiple technologies inside. So you can write a single service in Java, other service in Go or any other language that you want to have it, and that perfectly aligns with the use case that you have to solve. So you can use that. On the other hand, With microservices, you can respond faster, which means like you have a huge system of services, and then you want to quickly roll out new features. You want to test someone. You want to test some settings for a particular region of the user or something like that. Microservices are really, really helpful in that area because you can respond faster. You can deploy certain services, remove them, because every service is an isolated service, which means like it is much more easier for you to take that individual service out of the picture and your application will still work. This is the great stuff. On the other hand, microservices also gives you this fault isolation, where if you find a single node that is not working correctly, you can safely remove that node and then your application will still work. And you can also scale your application as and how you want to do it. Certain services, you might need more resources. For certain services, you might not even need more than one CPU resource and things like that. So you can scale your services as and how you want it. And that is also something very interesting with microservices. But so there are a lot of advantages using microservices. It kind of helps you to run your applications very faster. And also you can split your application into multiple chunks and it kind of works. But the main problem with microservices is, in case of monolith, all the problem of your application remains inside the application. So the code that you've written has the problems and you have to fix it. So if anything you have to fix it, you have to just go and fix the application. And all the intercommunications happening between the application is just a function call, which means like it's much more faster than compared with this one in the microservices, where all the communication happen between the services. And it is a network that you're depending on. And this network is not really reliable. So that is something you have to take into consideration. So here, this network introduces latency. This network gives a lot of problem. You cannot have 100% reliable stuff over there. And a single method call, for example, since everything is isolated, if your services are completely defragmented, then a single call will be like hopping through multiple services. And then you have to get the value from different services and then go it. While in the case of monolith, it's just a function call, but here it's a service-to-service communication, which is very complex for us to maintain. And there are a lot of problems around it. So that is something that you have to take into consideration when going for microservices. So consider that you have a very simple microservice example. So let's fall back to a service where you have the store, which is through which your users will interact with any of these services. So you have the store service, and the store service connects with a product service. And then there is an invoice service that is exclusive for creating an invoice. And then you have this notification which just sends out notification by connecting to SQS or SNS or something. So these are three different services. All these functionalities are segregated. That's how your services should be done. And all these services are isolated, which means like if the product service is down, the notification and invoice should still work. And that's how we have to design this entire system. It's a very simple use case, right? You just have 4 containers, just run this 4 containers, and everything will work out of the box, right? But that's not the case here. So once you have this 4 containers, all your users enter your application via store. So it stands out there, and all the services are here. So I mean, like in microservices, we'll say like any of these services can have multiple instances, which means you obviously need a load balancer at the top to equally spread the traffic that is coming inside. And all these services should interconnect and talk with each other, but it's very unreliable to go and update every time whenever you add a new service here or whenever you add a new service in the product. It is not possible to add everything together. So you need a mechanism through which everything should connect between themselves, and that mechanism is the service discovery or service registry, you can call it. So what is happening here is like if the store has to connect to invoice, instead of going straight away to the invoice, it goes to the service registry. It says like, okay, I want to connect with the invoice. Show me where invoice is, or give me the IP address or DNS name of the invoice. Once it says that, the invoice registry will look up in its table. It has a table in which, consider it has a table in which okay, invoice is there. It goes and connects to this DNS name. So it gives the DNS name. Then store can either connect to invoice via this route, or it can also ask the service discovery to go and connect and get me the data. So that's how it has to connect, and every connection should work. So we are actually adding one highly available service here. So if the service registry goes down, then you cannot connect to applications here. So all the requests that are coming to the store will have a lot of problem. So in that scenario, we need to make sure that this is highly available, and this also has a load balancer around it. This also has all the things around it to make it like to have a correct picture of whatever is happening. Any error here will cause errors here. So that is like we are creating a single point of failure there. So that is something that you have to consider when dealing with microservices. And then you need to have some mechanism where you determine the performance of the application, take care of the latency of the application, the throughput, how the routing is occurring, how various services connect with other services, how this entire thing is happening at an overall. And then you have to debug it. You have to find a mechanism, what is happening in a service, how the error is propagating, what are the different issues that we are seeing. And finally, you also have to have some alerting mechanism. If something is not working correctly, it should alert. It should say like, okay, so it is not working properly. I need to go and check here, or you need to go and check there. So those are the things that you need out of those microservices. These are not essential, but these are kind of, you should have it if you want to have a perfect working microservices. Okay, so it's a bunch of another highly available system. It's just like 4 or 5 services. Okay, you can manage with it. If that is the case, then you need to have a mechanism to authenticate all these stuffs, authenticate and authorize the requests that are flowing between the services. I mean, like you should prevent the DDoSing and all those things that is happening to the services. So you need to have some security here. And then some timeout mechanism. So the whole point of constructing a microservice is like, if you're designing microservices, the major thing that you have to think is it should not have a single point of failure. For example, if the store that goes and connects to invoice and the invoice service to which it is getting connected is not responding, and the store has like 1 million requests, and then all the million requests is trying to connect with the invoice, then you're creating a single point of failure there where the invoice is not responding back, but the store is keep on requesting invoice to give an update. Now, what will happen? Invoice is not working. The store will stop working because all the threads or whatever things that is running inside is waiting for the response from invoice. So you're kind of creating a single point failure via invoice, and that invoice kind of propagates this failure to store. Once store stops working, none of your users can come and access this entire system. So you have a huge problem there. So in order to avoid that, you need something called a timeout mechanism, where if a request is failed, or if the request is pending for more than 3 seconds or 5 seconds, you need to have this timeout mechanism. Says like, hey, stop, you should not request more. Okay, something you have to add. And other thing is like, okay, so failures are bound to happen in any of the systems. So when a failure happens, you need to have a scenario where you can retry. Okay, so this is failing, let me stop it, and then we have to retry one more time, whether it's working or not. You need to find out that thing. So a mechanism to retry. And also on the fly, you need to change something. So for example, if you're saying, okay, notification is having a problem in a South American region, then you just have to remove that entire stuff for that particular region. So you need to have this control mechanism somewhere, which kind of controls how your microservices behavior. So all those things are necessary, right? So you need to have a mechanism in which you can alter these control to the system, or you need a mechanism where you can find and fix the bugs that are happening in the system. And all those services that you're talking about are highly available services. Any failure here will cascade into a huge failure down the system. And that is a problem that we have to solve in the world of microservices. Is it stopped over there? No. We have a lot of other things like all those things. So considering everything is running as a Docker image, you need to have a replicas. You need to have like automatically restarting the missions whenever it fails. You need to save the state of the mission. and you need to monitor the health of the machine. And then finally, you need to have this entire chunk of layer which was hidden because of Docker, like the container, like the hardware, the operating system, the runtime, all those things. Docker actually helps a lot over here, but kind of like you have to think all those things. So a microservice as a whole, it has huge chunk of other unneeded components or other important components that you have to take into consideration. So this is a complexity of in the world of microservices. So initially we just started with this 4 application, and look how big it went. And it is just for just 4 applications to work properly. Okay, well, that looks complex, right? So if you're writing a greenfield application, or if you want to go to market faster and you don't have a complete setup for microservices, it is better to start with monoliths. Monoliths will really help you before venturing into microservices. Once you go into monoliths field, once you understand how you want your application to behave, microservices will actually be an easy thing that you can achieve once you have something working. So that would be a great thing. And if at all you're considering moving from monoliths, or if at all you're going to write something on microservices, take a minute, check this post from Kelsey Hightower. It is basically talking about what are the things that we are doing wrong in microservices and how we can improve it, and how monoliths are actually helping there. It is kind of like unpopular opinion talk, but it is really good, and it's a worth time to invest if you're trying to learn microservices and monoliths far deeper. So that is why microservices. It is more or less we concluded for just 4 applications that we have to deploy, we need a lot of boilerplate stuff that has to run here and there. And most of the applications that we talked are high available application. So, okay, so it is kind of manageable. And what are the tools that we have currently that helps? One of the major tools everybody's talking about is Kubernetes. So what is Kubernetes? So this is the entire thing that we have seen. So the first part of this entire stuff, all this container, hardware, operating system, runtime, Docker came in, and it kind of okay, so I will take care of everything. So you need not worry about those things. So it kind of helped us a lot. So it introduces the self-contained images, and it also added a complete portability to the system. So anything you can just move forward with just a single file. It is really an advantage. But the problem with Docker is it will not know how to manage your infrastructure, which means you cannot say okay, so just I'll give you a 6 GB RAM and then 100 GB of memory. Just go and put all the Docker containers inside. It will not know how to run and what to run inside. Yeah, this is it will not know when to run it, when a process is, you have to restart a process, and how to run the process, it will not know. It will just run the process and then makes it and consider that it's running. If it fails, then it say okay, it's shut down. It cannot even restart the entire thing. That is a problem that we have with Docker. So, okay, so you can clearly replace this chunk with Docker, but it's not enough for us, right? Because we need a mechanism where you can automatically restart. You need all this functionalities added to it. And that's where Kubernetes actually comes into picture. So what is Kubernetes? Kubernetes kind of helps you to automate the deployment. For example, you're running a replica of 2 Docker containers, and then say okay, whenever this thing fails, just restart it. Or whenever something is not working, or whenever your API is not working, just try to restart it. So it kind of automates the entire deployment. And it also helps you to scale up, down, in and out. So you can say okay, run 3 instances or run 5 instances for this stuff. It works seamlessly. It kind of helps you to achieve it. Whenever your resources go up, run it. Whenever your resources go down, you scale it down. So when you say those things, write a configuration for those things, it does it automatically for you. So you write it once, and it kind of helps you to do all those things. It manages the application. But the problem with Kubernetes is it doesn't have authorization and authentication inbuilt. You can say sometimes you can use it, but it's not built for that. So authentication and authorization is not perfectly there. And it doesn't give you a complete service discovery into the picture. It doesn't give a complete service discovery into the picture. It adds in service discovery. It helps you to achieve it. But on the other hand, it's not complete. So let me go here. Yeah. So the other thing is like it kind of decouples the infrastructure completely, which means like for in the world of Kubernetes, what you're saying is like, hey, Kubernetes, here is my system. Take the system, form whatever you want to form it there, but just run this a Spring Boot container for this many replicas. And it takes care of like partitioning your hardware. It takes care of like setting up the missions, setting up the nodes and all those things. And that is really helpful in the world of Kubernetes. And I would like to see Kubernetes as a running state of an application. So if you want to see how your application is running, you just go ahead and see the Kubernetes YAML file. It clearly depicts like how many instances are there, what are the things that are happening. So what does Kubernetes does is like it kind of replaces all the blue bars that I'm highlighting here. So it kind of replaces this entire chunk, and you can replace that with the Kubernetes. So Kubernetes kind of helps you there. So we kind of eliminated most of the problems that we have, but we still have some problems with respect to the connection of the system, which is the service discovery, and with respect to all the other containers, all the other essential stuff for your particular applications. Okay, I have a question here, so let me just open it. Yep. What is your opinion about macro monoliths and the new trend serverless? Yeah, I mean like serverless, micro monoliths are again, I would say it's again monoliths for me. It looks more or less similar, but serverless is really good. But again, at the end of the day, serverless, you're framing yourself to run on a cloud environment or on that scenario, and you cannot host everything on the machines. I think like any open source solution around serverless is not there. But I mean, like the natural evolution after Kubernetes and all those things is serverless, which kind of removes all these stuffs that you want to add in. But it has its own advantage and disadvantage. But if you have a need for going like, don't need to think about the infrastructure, don't need to think about anything at all, and just I have a function and just want to run it, serverless is a great thing over there. But sometimes you might need certain flexibilities, and that flexibilities are achieved with microservices architecture. Hope that the question is answered. Cool. So let me go back here. So the next stuff is Istio. And yeah, so Kubernetes actually helps you to remove a lot of redundant things that you have in the system. On the other hand, the Istio, what it does is like, let's see what Istio does. And just before that, so this is the application that we are going to generate today. It has a store, it has an invoice, it has a product and notification service. And all those things are interconnected. I'm just removing all the load balancers here, and all those things should be interconnected. So everything is interconnected here. And this entire structure is called a service mesh. It's a kind of like you can think of like a mesh of services that are interconnected. So both the way connections are there. Everything should talk with each other, and anything can talk in any direction. So this is this entire system is called a service mesh. So in this service mesh, it's quite easy to manage. But in the system of this level, this is actually from Netflix, I guess. This is a huge chunk of microservices that are talking with each other. So in this huge service, it is very difficult for you to control these services. Like you cannot control, say, like, okay, so this service should work only this location, and this service should not work. I have to decommission this product. I have to move some product to version 2 and some product to version 3. You cannot have this granular control with just what we have in Kubernetes. It's very difficult to enforce that control. And then it is also very difficult to manage these services. Here, manage means more or like you're decommissioning a service, or you're talking with a service, and then you have to manage how the talk should happen and what are the data confirmation between those services. It is very difficult to manage those things. And then you cannot secure these services. It's not very easy to secure these services, to authenticate and authorize these services. and also connection between the services. Now consider this many services should talk with each other, and then you have a single poor service registry, which kind of sits there and then tries to make all this communications to work together. It is a very huge problem to have. So we have this chunk of like whenever your scale grows up, we have this problem like you cannot control these services, you cannot manage them, securing them is very difficult, and connecting these services is also kind of very difficult. So that's where Istio comes into picture. So Istio allows you to control these services. Istio allows you to manage. It also enables a secure. It also adds a connection between these services. We will see the Istio YAML files that will be generated by JHipster. See how all these functionalities are achieved, or how each of these functionalities is achieved via the services. But it kind of helps you to do all those things, and it does it in a way that you don't need to change anything on your server side. So you don't need to add any mechanism inside your server or inside your code, inside your function, however you want to picture it. It doesn't add that thing inside of your own application. So everything is running externally, and you just plug this stuff, which makes it very, very easy because the component that you're plugging in is tested by the community. It has open source developed, so any bugs, all those things are correctly managed and everything is working perfectly. At times, there might be some bugs, but it's expected. But on the other hand, it kind of works everything out of the box, so you don't need to worry a lot about all those things. So that is the huge thing that you have there. So how does it work? So consider that you have the single application, and the yellow color box that I'm showing you here is the pod. So pod in the world of Kubernetes can have one or more containers, and that's how the Istio actually manages the entire thing. So inside a pod, you have your own Docker container, which is your application. You just add a proxy container inside the pod. The job of the proxy container is to accept all the incoming connections and also take a decision on all the outgoing connections. So instead of changing a code inside your application, what this thing does is like it adds a proxy container, and this proxy container actually gets the data, gets a request, and then it checks on the logics that you have provided. It controls it, it also authenticates, it collects the telemetry and all those things. It checks on all those logics, and then sends the data to store, sends a request to store, and the store in turn will get back, send its response to proxy, and the proxy will send it out to the original requester. Yeah, that's something really interesting, right? So this is good, but the very first question that you might ask is like, well, doesn't it add a latency to it? Because you're obviously adding one more layer on top of it, and it kind of adds a lot of latency, right? So that's this entire proxy is called envoy proxy, and what the envoy proxy is written in C and C++. C++ majorly, and it's very fast and it's very robust. It adds a latency, of course, to the system, but the latency is very minimal. And when you're trying to move towards Istio, this is something that you have to take into consideration because the latency will be added to the system, which means your normal application will have a little bit of latency. So consider like you're talking for any request, it goes to like 10 to 15 services. All this 10 to 15 services will have a proxy embedded in it, and all those proxies will have added latency to it. It might be in a little bit of nanoseconds or milliseconds, but still that is something that you have to factor out. So this is what is happening. So this is called as envoy proxy. It's just much faster. And so what it does is like instead of like all these connections to go through a service registry and different things, here everything what happens is like the store, everything is connected to Istio. Istio acts as a service discoverer. Istio collects your telemetry. Istio authenticates and authorizes. Istio also helps you to retry and all those logic inside. So you can have a single set of configuration with the help of Istio. And then you have this Kubernetes, which kind of maintains the entire architecture, which makes your microservices environment and development much more simpler and easier. And that's how Kubernetes and Istio makes it easier for you to develop microservices. Okay, Having said that, it's also important to understand like Istio on Kubernetes is built as a generic tool. And just like in programming languages, generics are always harder to build it, but to use it, it's kind of easier, but to build it, it's very harder. So both the systems are very complex, which means like you have to learn a lot before embarking a journey into it. Writing the YAML files, making your tabs and spaces correct is a huge thing that you have to think. It's a huge mind shift that you have to have. And that is the reason why sometimes they are confusing. But on the other hand, if you have these configurations built for you, it makes it easier for you to run your application. It kind of takes care of all the hard work that you have to do manually and all those things that was done by industry experts. And also it's developed open source, which means that anybody could contribute a quality code towards it. So that is something that you have to think before moving into Kubernetes and Istio. And I would say like if your use case is just this, like just you have like 4 to 5 services or like less than 100 services that talks with each other, then Istio is not mandatory. You can do all those things with Kubernetes and some other tool. But if you have like a huge chunk of microservices, like thousands of microservices or more than 100 microservices, then Istio kind of helps you to achieve that without any big differences. Cool. So that's the whole story behind it. So let's see what JHipster is. I have a question here. Cool. I haven't used Istio, but can we use console? Okay, but we use console at my place. How do they compare? That's a really good question. Yeah, so Istio is actually doesn't do any changes on the code, which means like it's something that lives external to the system. On the other hand, Console is also a service discovery. I think the latest version of Console also helps you to do most of the thing what Istio does. But on the other hand, the Console is built exclusively only for service discovery and service registry option. So how it works is like I also have a slide because JHipster also supports Console. So I will explain a bit more on that slide. But how it works is like Console is like it installs an agent on every node and then it kind of communicate between the node, and it is primarily built only for service discovery. On the other hand, Istio is built for service discovery, plus authentication and authorization, plus the management of service discovery, plus the collection of logics, collection of data and telemetry. So it kind of does everything altogether. So it's a complete package. On the other hand, Console is like just one single part of the system. And that's a major difference between them. So, and also Console is like multi-language possibility. So I mean, like you can develop in any language and Console can work on those languages. Istio also kind of helps you to do it, but it is something that lives outside the system, not inside the system. So that is what Console is and Istio compares to. Okay, so yeah, microservices is made easy with Kubernetes and Istio, but Kubernetes and Istio are much more complex. On the other hand, the JHipster, how it helps over there. So in the world of JHipster, so JHipster is nothing but a developer platform or an application generator that kind of helps you to bootstrap your application faster. We not only generate an application, we provide an opportunity to develop, deploy, and do a lot of things for the application. And that's where we would like to call ourselves as a development platform rather than like a complete application generator. So what it does is like it's a development platform. You can generate an application, develop it, and then deploy. So how the JHipster application look like? It's very simple. It's a full stack application, which means you have client side, you have a backend, and then you have the database and all those things. For the client side, you can you can have something like Angular, React, or Vue. You can choose whatever you want to have it. And then everything is written in TypeScript. So initially when we started, we saw like it was in JavaScript, like the Angular JS version, it was in JavaScript. But most of the backend developers love TypeScript because it adds types. And also it is kind of like much more similar to other languages. For example, for a Java developer, it's much more contextually easier to understand TypeScript. So that is the main reason why we moved all the scripts to TypeScript. So any backend developer feels that it is easier to do it. So we moved to TypeScript, and TypeScript is also awesome. That's on the front end. That's on the client side that we have. And on the back end, you can choose between Kotlin and Java. So there is a Kotlin version of it, which kind of replaces the entire backend with Kotlin code. And the application is actually built in Spring Boot. And right now we are working on changing, we are adding options such that you are not constrained only with Spring Boot. You can have this Micronaut backend or Quarkus backend. And also we have an option for stubbing this entire backend out and then replacing the backend with Node.js and things like that. So there is the possibility for you to add in whatever things that you want to have it. But here the main generator is basically on Java, and we have a Kotlin subgenerator. So the backend can be Java and Kotlin for now, majorly. And all the latest applications in the world should have some caching mechanism, and we do have multiple caching provider support. This is just a small view of the list, but there are a lot of other mechanisms that are available. And then you have this ELK stack. So we also generate ELK stack, so you can add an Elasticsearch, Logstash, and Kibana, everything together, the application that you're generating. So that is also possible. You can choose between Maven and Gradle here. So yeah, so that is for the build tool. And then on the database side, we do support the standard SQL databases and NoSQL databases like MongoDB, Cassandra, Couchbase, and all those things. And recently, we also added Neo4j support. And we also have reactive support at this moment. So it's a complete package that you can generate. So whatever Spring Boot helps you to do, it kind of generates everything together, adding a front end to it, adding a multiple build tools, and also creating all the Docker images along with it. So this is how an application in the world of JHipster will look like. Of course, it's like a lot of other things that you can have. There are a lot of different stuff. So I just took a snapshot of whatever that feels important and necessary. Yeah, I have a couple of questions. Let's go there. How granular can Istio? Okay. How granular can Istio go regarding authentication? Can it go beyond granting access to a resource entity? For example, granting access to an element of a JSON or query parameters. Okay, the question is like, how granular Istio go regarding authentication? Can it go beyond granting access to a resource entity? For example, granting access to an element of a JSON or query parameters? Well, that's a very good question. I think you can configure the query parameters, definitely. And to an element of JSON, I haven't seen that happening anywhere. But I'm not too sure. There might be a possibility. But with query parameters, you can do it with the help of like the configuration. For a path, you can do that. And the granularity is also much deeper. So here the granularity is like, you can dig down deeper as much as you want. But on the other hand, it's you have to take a decision whether you want to add all those granular authentication stuff via an Istio or via your application. So that is something that you have to think before doing it. But on the other hand, yes, you can do it for query parameters, but I'm not too sure about the JSON element. Okay, the next question is like, would you say JHipster is like full stack scaffolding? Yes, it's pretty much that. It is a full stack scaffolding generator. That's what we are. Added to that, we also have a bunch of other options. That's basically it. Yes. Cool. So that's what we are generating. On the other hand, we also have this Docker files generator for you. So any application that you're generating also has this Docker files, which means like it's ready to run in a Docker environment. And then you can also specially create a Kubernetes configuration files. That's what we're going to see today. So you can also create that. And added to that, since we are doing this both, and we are also helping developers to do all those things much more easier, we also have a bunch of CI/CD support. So whatever CI/CD that you're seeing here, like Jenkins, Circle CI, GitHub Actions, Azure Pipelines, GitLab Actions, or however they call it, and then Travis CI. So it kind of supports all those things. It kind of has all those CI/CD options. You can generate the YAML files. And we also provide support for like multiple cloud vendors. So you can actually create a Google application straight away, GAE straight away with a single click. And then you have AWS support, OpenShift support, Heroku, Pivotal Cloud Foundry support, and then Azure support. So everything is there. So even in Heroku, we have the single click to deploy. So you just have to click on a button to deploy your application, which is also pretty cool to generate and much more easier for you to get started with your application development. I mean, like if you're a developer and you're going to create an application and deploy it somewhere, I mean, like we could have, everybody can develop an application much faster. But this is a major chunk of work that takes a lot of time. One, we might not be completely comfortable understanding like different technology, and the terminologies change every now and then. So it is very difficult for us to follow up over here. And the generator actually helps you there because, for example, for Google Generator, someone from Google is coming and helping us. For Azure, there is a person from Microsoft that is helping us. So which means like they are on trend of what is happening there. They put in all the best practices, and it also helps you as an learning platform on top of which you can learn a lot of things. It's not only a generator kind of thing, but you can learn a lot with JHipster. That's how I was like so happy doing JHipster, because I learned a lot from it. So that's the entire suite that we are generating. So we also generate a microservice application. So how does a microservice application looks? So this is a general application. It's a Spring Boot based application with a front end. For example, here we have this React. And then you have this database. It can be a database, or it can be any user authentication provider, for example, auth2 and things like that. So there is an authentication service. And added to that, we added in this Zool proxy, and Zool proxy is responsible for like proxying all the requests that are coming to the service. And we call this service as microservice gateway. So this is the store application that we're talking about. It is a gateway for all the requests that are coming. So if you have an user, the user actually comes through the service to go inside your application. So this is where everything works. So it goes inside the application through this, and this is called as gateway. And then there are multiple services at the backend. These are like store, invoice, and then notification service. And it's also like these services may or may not have databases attached to it. So you can choose a database, or you can remove the database. So these can have database or cannot. You can choose as you want it. And they can be different databases. And these are called as microservice applications. The reason the naming is different is like this. Why I'm pointing out this naming is like when you're generating an application, you will see that we will ask like whether you want to generate a monolith or a microservice gateway or a microservice application. So obviously, gateway has the UI part in it and an user authentication part. The microservice application just has your function. It's considered as a simple function application. That's it. So if you want to drill deeper, if you want like more bigger picture, or this is how it works. So you have this your application that connects to the gateway, and then that has a list of microservices here. Here user authentication, authorization stuff, and then there is this service registry. So since we are talking about microservices, you can choose service registry between console and JHipster registry. And if you're choosing Istio, you need not have those two registries. You can just add Istio there. And also like we also provide a component called console, which helps you to find what is happening inside a service. And for that, we have this JHipster console. And that's basically it. So this is how an entire microservice application looks like in the world of JHipster. Of course, now we have an option or flexibility to change this with Spring with Micronaut or Quarkus. They are still in its early stages of development. And if you're interested, you can also start contributing towards that. So that's basically it. So the reference here, this is the slide that I was talking about, console and JHipster registry. In the world of console, console always wants to have consistency over availability. So it ensures consistency as a first level component. And it's kind of multi-node cluster in that sense, like there is a central server, and then there are smaller nodes that runs on every application that you have. And all those nodes connect to the central server, and the central server is responsible for maintaining your application and all those things. On the other hand, I'm sorry. On the other hand, the JHipster registry is a custom-built component on top of Netflix OSS. So it is actually having availability over consistency, and it's built with Spring Eureka and Cloud Config. Yeah, that's a difference. And JHipster registry is exclusive for Java since it has the Spring Eureka component and all those things. It's exclusive for Java and Spring-based applications. While on the other hand, console is exclusive for, it's not exclusive for a particular language. You can use any language that you want to have it there. So, so that's what I was telling. So the store is a microservice gateway, and these are microservice application. So it's time for some demo. Let's see whether it works. So let me go here. Let me go here. I have generated an application here already. So what is happening here? So this is one instance from GCP. So it is like a normal compute server. And then I have this, so I've generated with Kotlin Hipster, which is all the code that has to be here is a Kotlin. And there is also Java version available. But both are same, just a single word difference, that's it. So this is how you will generate an application. So let me shrink it. So in the world of JHipster, you can generate an application either with this or something like this. For example, let me create a new folder. Hope the font size is okay. If the font size is not okay, just let me know. I'll increase the font size. So let me create an app here. So let's call it as an app, and then go inside the folder. And then I type JHipster here. And yeah, just before that, if you want to install it, you can install JHipster like this. It is npm module, which is a JavaScript package manager. Just an npm module. You have to have Node for it to work, and of course Java. And then you just run npm install -g generator JHipster. So once you have done this, you can type in this command JHipster. So once you type in this JHipster command, it goes and asks multiple questions for you. Okay. Yeah, my system is kind of slow. I don't know what is happening there. Okay, let me just click. Let me restart it again. Okay. So the first question is like what kind of application that you want to generate. So you can choose between a monolith, microservice application, or gateway. And you can also create your own user authentication and authorization server with the open source stuff that we have built. So for example, I'm creating a microservice gateway. The Spring Web Flux is in beta support now. I'm not choosing it now, but if you want, you can choose. It's kind of really nice to have. And a base name of your application, the port in which it has to run, the Java package name. And here is the interesting thing. So what kind of service registry that you have to use. You can choose between JHipster registry, console, and no service discovery. You can use no service discovery if you're going to use Istio, because Istio manually adds it. And then for authentication, you can choose between JWT, auth2, or the JHipster UAA authentication server. So let's go just the default one, which is JWT authentication. And the database, as I was saying, you can choose any database here. For example, you can choose an SQL database, which has multiple different options in turn. And then MongoDB, Cassandra, Couchbase, or you can say, I don't need any database at all. So for example, if you choose SQL, you can choose one for production. For example, let me choose PostgreSQL for production. And for development, you can choose either H2 or PostgreSQL, which makes it easier. And this is the cache. So you can use any cache that you want to have it here. So let me choose the default one, and then the Hibernate second level cache, which is essential. And the classic question whether you want to use Maven and Gradle. You can use anything, but let me use Gradle here. And yeah, so you can also add an Elasticsearch, Spring WebSocket support, or Kafka generator, or an Open API generator. If you're creating an API-based development, you can choose any one of them. You can also choose a framework that you want to choose. And another thing to note is like you can choose no client here. If you have chosen no client, which means like we will, of course, will not generate any front end. So you just have the back end of the application. So it's just an API endpoint for you. And then you can choose any theme that you want to have. We also have I18N support. You can choose multiple different languages. And then you can also choose any extra tooling. For example, Gatling for load testing, Cucumber for BDD testing, and Protractor for end-to-end testing in the front-end world. And that's basically it. And then you can also add in multiple other things. There is a marketplace attached to it. There are blueprints and modules, which is itself a separate topic. I've add the links for that, but you can add all those things required. So once you click on enter here, it goes ahead and creates an application. Let me just skip the application and go back to my. So this is how an application will look like. So this is a store application. So if you take a look here, it is a simple Java application with all the necessary stuffs that you want to have. So source, main, we generate the entire set of Docker files for you. So your application is ready to run Docker from day one. And then since it's a Kotlin-based application, it has all the Java files, Kotlin files, which are indeed in turn goes back into Kotlin Java files. So it's a Spring Boot application with Zool proxy enabled and a bunch of configuration stuff and your main function to start your application. So these are the things. And then you have this web app, and web app is actually written in TypeScript. It's a React-based application, so everything is in TSX. But again, like it adds in all those things that you want in a system. It creates everything for you. So that's how a single application will look like. But on the other hand, it doesn't end with an application, right? So it's not only application. Sometimes you want to add entities to the system, or you want to add, you want to add entities to the system. You want to, in the world of microservices, you want to couple multiple applications together. So during that scenarios, that's where this JDL comes into picture. It makes it much more easier. JDL is nothing but JHipster descriptive language. So what it does is like, you can generate an application by providing this DSL. So it's a like application, generate me an application with the configuration, all the information that we have provided. So I've said like no service discovery, authentication type is JWT, the database is MySQL, and build tool is Gradle, plan framework is React. And what it does is like all the things that you have given here, it will take the value that you've provided, and for all the other values that you have not provided, it just takes the default value. And I'm also saying like create entities for it, and then I put a star here. So what does it mean? So I have my entity defined here. These are nothing but a JPA entities. So entity, a customer, so every entity is a table. And then you have this columns here, the first name, string, required, and any patterns or any validations that you want to add. So we will generate all the custom classes for that. And the cool thing about that is like you can also generate an enum and use that enum inside. So here, for example, for gender, we have used the enum here. So you can also have this thing there. And you can define a relationship. So you can define one-to-one, one-to-many, many-to-one relationship with this. So that's how you define an application. Since it's a gateway application, we have to generate user interface for all the entities that is in the system. So that's the reason why we put entity star here. And then you have this product system, so product service. In the world of product service, it is just a microservice, but here it's a gateway. Out here, it's just a microservice. And it has the same authentication type, and it's also using MySQL. But here we are defining, okay, just use these entities for the system. So for product system, it just makes sense to have product related entities there. So it just says like, okay, just use these entities that I have defined here. So if I go here, so here I have product, which is a list of product and all those values inside it. And then you have this invoice system where it's also a microservice. It's also using a MySQL database, but it just used two other entities. And similarly, you have this notification system. And inside notification system, you have the centered database and all those things here. So it's a very similar stuff. But now what you have is like just a single file with which you can generate all the applications like anything. So how you can generate it? We have a subcommand called JHipster import -jdl and a subcommand of, I mean, like on the file name JDL app.jdl or something. And you can also do that with JHipster if you want Kotlin files, which is JHipster, the same command, import JDL app.jdl. So everything remains the same. The only difference is that it generates Kotlin file instead of Java files. That's the only difference. So once you run this, run this entire thing, this is what you're seeing. So so this is the app.jdl that I've run. So if you take a look, you have this invoice, notification, product, store. All those things are different services. So all those things are generated. So once those things are generated, for example, this is notification, which is again a simple application, but it doesn't have any web-related code in it. I mean, like there are no UI attached to it. So that's how it works. And then I can also show you how the entities are generated. So for any entity that you've added, so for example, check if there are any entity. Yeah, so we took notification entity. So notification entity has this RS controller attached to it, with which you can create, update, and all those things and normal stuff. On the back end, it has a repository which is based on JPA repository, Spring Data. And the domain is basically just a notification with a data class. That's it. So it kind of generates and stubs out all these things. Since it's Kotlin, it gives a data class. But in the world of Java, I do have a Java application here. Let me quickly show that. So in the world of Java, the same notification. If I go here, it has the same thing, but it generates in Java side. That's basically it. So here you can take a look. It's just a notification class with all those entities, all those things added to it. So it kind of makes it easier for you to generate an application. So that's basically it. So it generates an application. Now, once the application is generated, the next step is like you have to run it somewhere, right? And for running it, let's use Kubernetes. Let me create a folder called Kuber. So in order to generate a Kubernetes configuration file, what you have to do is like you have to run this command, JHipster K8s or JHipster Kubernetes. So once you have done that, it again checks whether any necessary things are there. And after that, it asks you a bunch of questions. You just have to answer those questions. So here it asks whether you want to generate an application for microservice or monolith. So let me just tell microservice where my actual services are there. So once I've given that, it went ahead and then saw these services and then lists down these services. Let me just go ahead and select all the services. And then it asks like whether you want to add any monitoring to the system. Right now, we don't need monitoring because Istio adds in Grafana and Kiali for monitoring. So we will say no for now. But if you want, you can add it. And in the Kubernetes world, namespace is kind of a folder within which all your application you can categorize. So in this case, let me just say default here. And then give my Docker repository because I have to create a Docker image and then push that Docker image to the cloud and use it inside Kubernetes. So I need Docker image, I need a Docker repository, and a command to push the image for the Docker. I want to add Istio because I don't have any service discovery mechanism. So let me just choose S here and an IP. So this should be basically my Istio IP. So if I go back, okay, if I go here and then choose my Kubernetes clusters. So I have my cluster up and running here, and then I have to click this one. Okay, it's too slow. It's very slow. Okay, so it is. For example, here in this case, where is it? No, not here, sorry. It should be on services. Okay, just when it loaded, I'll just add a story here. So yeah, so I created a Kubernetes cluster that is running on GCP and also installed Istio in it. So it has all the Istio services here. And in Istio, it has this ingress gateway. Ingress gateway actually gives the load balancer. And I mean, like it gives an external IP through which you can connect. So in my case, the external IP is like 35.202.752. And I'm just going to use that IP over here, which is 35.202.752. And I just click on enter here. Nib.io is an extension that I've added. It kind of helpful for you to navigate it faster. Nib.io is really cool because it kind of redirects whatever URL that is giving to it. And it kind of gives a DNS name for your application. And that's the main reason why I added nib.io. And you can also add in dynamic provisioning of storage. I'll just show no here. So once it is done, what you see is like this bunch of services that are created. So let me go back here, refresh this thing because it's in remote. Close this. Yeah, I have this Kuber folder. So if you take a look, it creates apply command, and inside apply command, what it says is like, yeah, just create apply commands for these set of functionality for invoice, for notification, for product, and for store. And if you take a look at the store, what it has is like, it has a secret. Of course, all your services should talk with each other. So there should be some secret available. So it gives the secret somewhere. And the deployment is where you're defining the image of your application. So here, I'm just saying the case store, which is my application name. So here, at first, I'm saying like, wait till the DB is up. So wait till the database is booting up. Once it is done, download the image from this location, and then try to run the entire application. These are my configuration options. And then you have this MySQL for your database, because that's a database that we have chose. And the service is the service wrapper. The main intention of service here is like, just like, okay, running something is running on 80 port, and then I redirect it to 8080 port. That's what this entire thing is. So these are like normal Kubernetes configuration. Since we have also added Istio, what it does is like Istio adds a rule, destination rule. This is where you can actually control the application. So you're saying like, okay, so maximum of 30 connections that you can do it. The connection timer is 100 millisecond. Any request that takes more than 100 millisecond will automatically get a timeout. And it also gives like how many retries that you can do and all those things. For example, here I can do 5 retries and something like that. And all those things like outlier detection. So when some error is happening, how you have to handle it and all those things. And it also adds in a virtual service. The virtual service is kind of a load balancer. So here you're saying like, okay, so destination is K-store. If the tag is B1, just send all the requests to it. So you can also say like, if it's B1, send 50%, B2, send 50%. So this is where actually you're doing the load balancing stuff. And also, it also adds, when you're doing load balancing, you can also have this like retry for 5 times, retry for 3 times, and every retry add 2 seconds to the retry options and things like that. And then you have this gateway service, which is kind of a service on top. This is the imaginary proxy service. So actually, this with which you can control the proxy and the data that is entering into the application. And this will be the original host address. So what I can do is like, I can just copy this. I hope this is running here. Yeah. So as you can see here, this is an application. I just signed in with admin. And then you can see a list of customer stuff here. So I can also add anything here. It also adds a pattern matching here. So you have to type something or else it will have an error and things like that. So yeah, it does everything. And then it also gives an admin module. Inside admin module, you have set of users, the metrics, how to connect things and all those things. You have the health of the application. So metrics actually gives entire statistics of your JVM, your request, and what are the requests that are failing, what are the requests that are happening, how many cache elements are there, and all those necessary detail for your application to run. And health actually tells how your health of the application is. And the reason why it is unknown here, because we are using Istio, which is completely excluded from the system. And that's basically it. So this is an application, right? And then you might want to debug this application. For example, if you go back here, if I take a look at this, I actually have two such applications running, which is like the things that start with K are Kotlin-based services. So all this K invoice, K notification are running perfect, but there is a red mark in the system, which says like, oh, it seems like notification service is not working. And why it is not working? If we don't know why it is not working, right? And for that, we have something called a scalable. So scalable is observability monitoring tool, which kind of helps you to monitor an application. So for example, I have like a default namespace, Istio system namespace, and JHipster namespace. So in my default namespace, I have one application that is failing. So let's see what is happening there. So if I take a look at the notification, it has like notification and workloads and services. Services should be running fine because it is just a mapper or a load balancer kind of thing. So it is not having any problem. But on the other hand, if I can go to that workload and then check. So, okay, so this is a JHipster application. This is an actual application log that I can see. And here you can see like it cannot connect to the MongoDB because this application is generated with MongoDB. So it cannot go and connect to that particular instance. And that is a problem, right? So it is not working correctly. And that is the reason why it's showing an error. So it makes it much more easier to see a log and errors over here. On the other hand, okay, so what if you don't have Istio? You just have Kubernetes. It's also easy in the world of Kubernetes. If you go here, Kubernetes actually provides a detailed information. And if you click on this container logs, this is the new view. You might not see it, or if you're signed up for beta, you might see it. I'm not sure how it works. But here, if you take a look, it gives a complete picture of what is happening inside. It gives all the error stuff. So it gives a complete filter. So this is Stackdriver, which also helps you to debug your application much more faster and much more efficient. And that's how it is advantageous. And also Kiali, on the other hand, has this graph feature, which is very nice because it shows what are the applications that is talking, how the talking is happening between the application. For example, there is a call that is happening between here, and then here and here. And this is happening via TCP. And what is the incoming traffic? What are the outgoing traffic? And all those things. Yeah, so that's how Istio is very useful to have this communication properly channeled, and also to find out what are the bottlenecks that you have in the system. And that's basically it. Let me go back to slides. Yeah, so that's basically it. So JHipster as a whole helps you to generate an application much more faster, but Kubernetes and Istio helps to deploy and maintain the application much more easier. That's the entire crux of this thing. And then you have this JDL sample. Suppose you want to just try it out. You want to understand how various JDL stuffs are working. You can use this JDL samples repo where you can just go there. It has a bunch of samples for you. You can just pick any application and try running it. JHipster is the link for JHipster is here, and also the link for KHipster is here if you're more into Kotlin. Yeah, and that's basically it from my side. I think there are a couple of questions here. Just go there. Okay, the first one is JHipster sounds really cool. Thanks a lot for that. If you want to prototype or put something together pretty fast, but I'm wondering how cumbersome becomes maintain or modify JHipster generated application. Yeah, this is a very good question, and this is a question that I have been personally asked a lot. We do have a command called JHipster upgrade, and that kind of helps you to upgrade the applications much more faster. But on the other hand, what JHipster does is like it just generates a Spring Boot based application, and then with some UI attached to it. And you can go ahead and customize any part of the application as and how you want it. It's just a boilerplate for you with which you can generate an application and then stick onto the application. That's one thing. And number two is like, if you really want to make use of this community stuff and all those things, then I would suggest like have this JHipster generated application. Every configuration is a bean with a Java file or a Kotlin file. Just extend that Java or Kotlin file, and then create your own file and then use it. So where it helps, like when you try to run JHipster upgrade, you can obviously replace all the JHipster code by the code that is provided by JHipster, and then just modify the custom code that you have written, which makes it much more easier. So yeah, so it is useful in that terms. But yeah, I mean, like I've personally done more than 15 to 20 applications with JHipster, 20 products with JHipster. And it was pretty stable, and I've been updating it a lot. Initial times when we started the application, like JHipster 5 or 4, there was some problem with the upgrade command, but now it's like more or less consistent. And I can also share a link where there is a side-by-side project generation that kind of helps you like what the impacts that you can have and how you can manage those things. That will really help you there. Okay, the next question is like, what if I need to manage configuration per different environment? Do I need to use Kubernetes and Spring Boot features for it, or JHipster provide already to handle? Yeah, I mean, like you have the standard dev profile. I mean, like if that is the thing that you're asking, yes, there are dev profile, pro profile, test profile, and all the other profiles with Swagger, without database, or with everything else. So those are also available. So the configuration is pretty standard. And yeah, it's just a Spring Boot based application. If you want, you can just go ahead and modify all those things, whatever you wanted there. Good. Any more questions? I would be more than happy to answer.
I think, yeah, we don't have more questions. Well, we have your social network here, your Twitter, your GitHub, and also your dev account. If anyone has more questions, please follow to Sandil. He's a great guy. I don't want to keeping you awake because I know it's 3 a.m. there. But thanks a lot, Sandil. It was a complete talk, and well, it's so complete that I don't have any question to you. So great to have you here, and well, hopefully in the future we can have you in another virtual meetup of any kind of event we are organizing here in Guadalajara.
Yeah, awesome. I'm looking forward to that. Thanks a lot for that. And have a great day, everybody. And just reach out to me if you have any questions. I'll be more than happy to help. Yeah.
Yeah,
Thanks
sure.
a lot. Yeah.
And guys, don't forget to follow us. We have our Twitter account, Java _GDL. We can follow there, and also in Facebook. Hara Java User Group. So thank you guys, and see you later. Bye, Santiago. Thank you.
Yeah. Bye.